Hello, everyone, and welcome to the Environmental Science and Engineering podcast. In this series, we'll be taking a close look at the water and wastewater management systems of some of the most unique cities in the world. In each episode, we'll explore how different countries are addressing the challenges of water stress.
Yes, in this series, we'll explore key questions like how water is sourced, how it is treated, and how it can be reused effectively. Because today, water management is no longer just an environmental issue, it's a strategic necessity that shapes the future of cities.
Our first stop is Singapore, and that's for a reason. Singapore is truly one of the global pioneers in water management. With its diversified sources and use of advanced technologies, it's become a model for many other nations.
In this episode, we'll explore how Singapore obtains its water, how it's treated, and how wastewater is reclaimed and reused. So we'll basically walk through the entire urban water cycle of the city.
If you're ready, let's dive in and take a closer look at Singapore's water management strategy. In this part, we'll focus on Singapore's water stress. Let's start with some key facts. What is Singapore's area and population?
Singapore is a small island city-state with a land area of about 735.7 square kilometers. As of 2024, its population is estimated at approximately 6.04 million people. That gives it a population density of around 7,800 people per square kilometer, which is among the highest in the world.
All right. And what exactly do we mean when we say water stress? How is it measured?
Water stress is measured as the percentage of total renewable freshwater resources that a country withdraws each year. It takes into account environmental flow requirements, so it reflects how much water is actually being used relative to what is sustainably available. This is a standard indicator used by many international institutions.
So, does Singapore experience water stress? How high is it?
Yes, Singapore is classified as one of the most water-stressed countries in the world. It withdraws around 83% of its renewable freshwater resources. That's considered extreme water stress. Anything above 80% is categorized as very high.
And what about natural freshwater resources? Does Singapore have any?
Singapore has very limited natural freshwater sources. It lacks large rivers, lakes, or underground aquifers. Despite having a high annual rainfall, about 2,400 to 2,500 millimeters per year, its limited land area and storage capacity make it difficult to fully utilize this rainfall. That's why rainwater harvesting plays a critical role, which we'll talk about in a moment.
So we have limited resources and high stress. How does Singapore manage this?
Singapore's answer is very strategic, the four national taps approach. This model ensures water supply from four different sources: rainwater, imported water from Malaysia, reclaimed water, known as NEWater, and desalinated seawater. By combining these sources, Singapore strengthens its water security and reduces dependency on any single source.
Sounds like a very comprehensive system. Let's start with the first national tap, rainwater. How effective is this in a small country like Singapore?
Despite its small size, Singapore receives a high amount of rainfall, around 2,400 to 2,500 millimeters annually. Because of this, about two-thirds of the country's surface area has been engineered as water catchment zones. Rain falling on these areas is collected through an 8,000-kilometer drainage network and directed into 17 major reservoirs.
So the whole city sort of acts like one big rainwater collection system?
Exactly. The city infrastructure is designed to channel rainwater. Rooftops, roads, even open spaces all contribute. These areas feed into both large reservoirs and smaller urban subcatchments, enabling decentralized collection as well.
Can the collected rainwater be used directly?
Not directly. All collected rainwater is sent to treatment plants operated by the National Water Agency. There, it undergoes physical, chemical, and biological treatment to meet drinking water standards. Once treated, it can be used for domestic and industrial purposes.
That's quite impressive. Do we know how much of Singapore's total water demand is met through rainwater?
Yes, currently, rainwater accounts for about 20 to 25% of Singapore's total water demand. However, since rainfall is seasonal and uneven, rainwater alone isn't reliable. That's why it's used alongside the other three national taps in a hybrid system.
So rainwater is a sustainable but variable source. Is climate change putting this system at risk?
Yes, and that's why Singapore regularly updates its water strategies based on climate projections. More frequent intense storms or prolonged drought spells can affect reservoir yields. So it's not just about collecting water, it's also about storing and distributing it efficiently.
So this is not just an infrastructure challenge, but also a planning and management achievement.
Absolutely. Singapore is almost like a live experiment in urban water management. There are very few countries that manage rainwater as part of an integrated national strategy. And this is just the first tap. You'll be even more impressed as we move on to the others.
I remember those giant tree-like structures in Singapore that attract a lot of tourists. Do those collect rainwater too? I think I read something about that.
Yes, those are called the super tree grove structures, and they're not just visually stunning, they also play a functional role. These vertical garden structures channel rainwater down through their trunks and into underground storage systems.
So they're not just iconic, they're environmentally functional.
Exactly. The collected rainwater is used for irrigation at gardens by the bay and even in some cooling systems. We don't have precise public data on how much water they collect, but they are known to contribute significantly to daily non-potable water use.
We discussed how Singapore has turned rainwater harvesting into a valuable internal resource. Now it's time to explore the second source, imported water from Malaysia. For a small country like Singapore, how is water importation from neighboring countries managed strategically?
Yes. Importing water from Malaysia is actually the oldest component of Singapore's water security strategy. Water's piped in from the Johor state in western Malaysia through a series of pipelines. This system dates back to colonial times, specifically the British era. The first agreement was signed in 1927, followed by two major treaties in 1961 and 1962. Under the still active 1962 agreement, Singapore has the right to draw up to 250 million gallons per day, roughly 946,000 cubic meters, of raw water from the Johor River.
That's a substantial amount. Does Singapore use this water as it is, or does it go through treatment?
Singapore doesn't use it directly. All imported water undergoes thorough treatment at its own facilities before it's distributed. Interestingly, a portion of this treated water is even sold back to Malaysia. So Singapore isn't just a passive water recipient. It adds value by processing the water, which puts it in a stronger position than just being a buyer.
Is this agreement permanent? Can Singapore count on this source in the long term?
Well, that's where things get a bit complex. The water agreements with Malaysia have occasionally led to diplomatic tensions, especially regarding pricing. The Malaysian side argues that the price has remained too low for decades and should be revised to reflect today's economic realities. Meanwhile, Singapore insists the terms are legally binding under international law and should remain unchanged.
So this source is both a major asset and a potential diplomatic risk in terms of water security.
Exactly. That's why Singapore is actively strengthening its other water sources like NEWater, desalination, and rainwater harvesting. In fact, in some years, Singapore deliberately reduces the amount of water it imports and relies more on its domestic sources. This aligns with their long-term vision of building a self-sufficient and resilient water system.
After discussing rainwater harvesting and water imports from Malaysia, it's now time to move on to the third tap, NEWater. This is arguably one of the most innovative and groundbreaking strategies in Singapore's water management. So what exactly is NEWater?
NEWater is Singapore's high-grade reclaimed water, produced by treating wastewater through advanced purification processes. Primarily, it involves domestic wastewater, collected from the sewer system, which undergoes advanced treatment and then is reused in industrial facilities, cooling towers, or added to reservoirs to support the drinking water supply. The most crucial part of this process is the use of advanced membrane filtration technologies.
So this isn't conventional wastewater treatment. It's a much more advanced system, right?
Absolutely. NEWater follows a three-stage purification process. First, microfiltration, or ultrafiltration, removes suspended solids, bacteria, and some viruses. Second, reverse osmosis membranes eliminate dissolved salts, organic molecules, and even trace heavy metals. Finally, ultraviolet disinfection ensures the complete removal of pathogens, making the water microbiologically safe.
When did the NEWater concept emerge in Singapore? What's the historical background?
It goes back further than most people think. The Public Utilities Board started working on advanced water treatment technologies in 1998. By 2000, the first pilot NEWater plant was operational for testing. After successful trials, the first full-scale NEWater facility opened in the Badock area in 2003. That same year, major public outreach and awareness campaigns were launched to build trust and understanding.
So it's something that developed over the last 30 years, and clearly it's far beyond what many people think of when they hear recycled water. Can people actually drink NEWater?
Yes, NEWater is of drinking water quality. However, Singapore doesn't usually send it directly to the taps. Instead, it's blended into reservoirs, where it's diluted naturally, and then sent through conventional water treatment plants. This approach helps ease public acceptance from a psychological standpoint.
So it's like a transitional strategy designed to reduce what we previously called the yuck factor, a way to make people feel more comfortable with the idea of drinking recycled water?
Exactly. Singapore didn't just solve the technical challenge, it also managed public perception exceptionally well. There were education programs, transparent communication, and even bottled NEWater used in public taste tests. Over time, people's attitudes shifted positively.
And by the way, on this podcast channel, we also released a separate episode focusing solely on membrane filtration technologies. If our listeners want a deeper dive into the science behind systems like NEWater, we highly recommend checking that out.
Yes, in that episode we covered how microfiltration, ultrafiltration, and reverse osmosis work, along with how gray water, rainwater, or wastewater can be treated using these methods. NEWater is one of the most advanced real-world applications of these technologies.
So NEWater represents more than just engineering. It's a blend of science, social strategy, and long-term planning. Truly impressive.
Absolutely. It's a critical milestone in Singapore's journey toward water independence.
We've explored NEWater in depth, and now it's time to move on to Singapore's fourth and final water supply strategy, desalination. Since Singapore is an island nation completely surrounded by the sea, how is this resource being utilized?
You're absolutely right. Tapping into seawater has become one of the most significant steps in Singapore's path to water independence. Desalination, turning seawater into drinkable and usable water, forms the fourth pillar of Singapore's 4 national tap strategy. Currently, there are 5 active desalination plants in Singapore. Sing Spring Desalination Plant, commissioned in 2005, was the first facility of its kind in the country. Tuas South Desalination Plant, formerly known as Tuas Spring, came online in 2013. Tuas Desalination Plant began operations in 2018. Keppel Marina East Desalination Plant, opened in 2020, is the first hybrid facility capable of treating both seawater and freshwater from reservoirs. And most recently, the Jurong Island Desalination Plant, which became operational in 2022. Together, these 5 plants produce around 190 million liters of potable water per day, accounting for approximately 30% of Singapore's total water demand.
So desalination has moved beyond being a backup plan. It's now one of Singapore's primary water sources. But what are the biggest challenges with these systems?
One of the major challenges is high energy consumption. These plants primarily rely on reverse osmosis, which is an energy-intensive process. On average, it takes about 2 kilowatt-hours of electricity to produce 1 cubic meter of desalinated water. This significantly increases operational costs and contributes to the carbon footprint.
And what about the environmental impact, especially the concentrated salty brine that's discharged back into the ocean?
That's a critical issue. The brine, if not carefully managed, can be harmful to marine ecosystems. But Singapore is very cautious in this area. The plants dilute the brine before discharge and monitor both temperature and salinity levels to reduce environmental stress. In addition, continuous environmental monitoring systems are in place to ensure the discharge remains within safe limits.
So it sounds like desalination isn't just a short-term emergency fix, but a fully integrated long-term strategy.
Absolutely. Especially with the increasing risks brought by climate change, like reduced rainfall and fluctuating reservoir levels, seawater becomes a virtually unlimited and reliable resource. That's why desalination is now an indispensable component of Singapore's 4 national TAPS framework. And on a broader level, investing in water and wastewater infrastructure is one of the most critical long-term moves a country can make. Infrastructure reflects a nation's priorities and resilience. These aren't short-term projects. Treatment plants, water supply systems, and sewer networks are designed to last 50 or more years. That's why careful planning and future-proof design are essential.
Exactly. Once you build a city, you build the foundation for generations. The way you start determines how things evolve. It's like how the U.S. designed cities with planned streets and avenues centuries ago, and they're still functioning well today. If you start with poor planning, correcting a badly built city is extremely hard. So when designing from scratch, you need to think 100 to 200 years ahead. That's why urban planning and disaster resilience are some of the most important responsibilities of any nation.
Exactly. And while we could talk about urban infrastructure and planning all day, we'll save that for another episode. It deserves its own deep dive. For now, let's get back to our topic, Singapore's water strategy and how desalination supports its long-term sustainability.
We've now covered Singapore's 4 main water sources: rainwater harvesting, water imports, NEWater, and desalination. But securing water isn't just about supply, it's also about recovery. This is where NEWater plays a key role. So how does Singapore collect and treat its wastewater?
That's a really important question. Wastewater recovery is one of the strongest links in Singapore's water loop, and at the core of that system lies the globally recognized Deep Tunnel Sewerage System, or DTSS. It's a network of deep underground tunnels, some reaching 50 meters below ground, that rely on gravity to convey wastewater across the country to centralized treatment facilities.
So this is a very different approach from traditional decentralized sewer systems, right?
Absolutely. DTSS consists of 2 phases. The first phase was completed in 2009, along with the opening of the Changi water reclamation plant in the east. The second phase will cover western Singapore and will connect to the Tuas Nexus mega project expected to be fully operational after 2026. Together, these phases will create a national, centralized, and sustainable wastewater management system.
And where does the wastewater go once it flows through these tunnels? What treatment plants are currently operating?
As of 2024, Singapore operates 4 major water reclamation plants, or WRPs. Changi WRP, located in the east, it's the largest facility and deeply integrated with NEWater production. Daily capacity is 800,000 cubic meters. Ulu Pandan WRP in the west, in operation since 1969 but continuously upgraded, it's used to test advanced technologies like membrane bioreactors and biological phosphorus removal. Kranji WRP, situated in the north, compact and modular, also supports NEWater production, and Jurong WRP, serving the southwestern industrial zone, specializes in industrial wastewater treatment.
So both domestic and industrial wastewater streams are treated across different plants, each one serving specific areas. Are there any new innovations coming up?
The most exciting development is Tuas Nexus. It's a massive integrated facility that will combine the Tuas water reclamation plant with the waste-to-energy facility. That means both wastewater and solid waste will be processed in the same complex. The goal? To become energy positive. The facility will generate enough energy from wastewater and organic food waste to power itself. Like Changi, its treatment capacity will be 800,000 cubic meters per day, and notably, it's set to host the world's largest membrane bioreactor system. What's more, co-digestion will be implemented. This means sludge from wastewater and organic food waste will be digested together in anaerobic digesters to produce biogas. That biogas will be used to generate electricity and heat, enhancing energy efficiency and reducing the facility's carbon footprint.
And that'll also relieve some of the pressure on Changi and Ulu Pandan. Truly a holistic approach. But what happens to the treated wastewater?
This is where NEWater comes in again.
Treated wastewater from plants like Changi and Kranji goes through advanced purification, including membrane filtration, reverse osmosis, and ultraviolet disinfection. The result is high-quality reclaimed water that is chemically and microbiologically safe. This water is reused for industrial processes, cooling towers, and even replenishing reservoirs where it mixes with rainwater before being sent to drinking water treatment plants. We actually have a whole episode dedicated to this topic, so if any of our listeners are curious, we highly recommend checking out our episode on NEWater.
So in Singapore, wastewater isn't just treated, it's transformed into a valuable resource, a powerful example of sustainability in action.
Absolutely. Singapore is showing the world how water can be managed within a circular economy framework. For countries facing water scarcity, this model is not just inspiring, it's essential.
So far, we've explored how Singapore diversified its water sources, advanced its wastewater treatment systems, and integrated everything into a national strategy. But how has the public been involved in all of this? How has the value of water been communicated to people?
This is actually one of Singapore's biggest achievements. They didn't just build technical solutions, they shared them with the public and ensured people embrace them. That's thanks to a strong public communication and education strategy. With simple yet powerful slogans like "Every drop counts," the value of water is taught from early childhood.
So people aren't just passive users of the system, they become active participants.
Exactly. A great example of this is the NEWater Visitor Center. Here, both students and the general public can witness firsthand how advanced water treatment works. Visitors can even taste the reclaimed water. These kinds of experiences are very effective at breaking down the stigma around reused water.
It's all about building trust, not just in the system or the technology, but in the water itself.
Right. PUB also organizes awareness events every year as part of Singapore World Water Day. For an entire month, they run campaigns involving competitions, seminars, marathons, and social media outreach to raise awareness on water issues. They also provide tools and guides for water saving at home, because water consumption isn't just a technical matter, it's also about behavior.
And all these public awareness efforts also play a key role in Singapore's response to climate change.
That's a great point. As a low-lying island nation, Singapore is particularly vulnerable to the impacts of climate change, changing rainfall patterns, rising sea levels. That's why water management is seen not just as infrastructure, but as a national security and climate adaptation strategy.
So they're developing integrated solutions for both drought and flood risks.
Yes, for example, rainwater harvesting isn't just for water supply, it's also a tool for flood control. At the same time, systems like NEWater and desalination provide a self-reliant water supply, helping to build a resilient city in the face of the climate crisis.
It really is impressive. Technical infrastructure, social awareness, and climate resilience all working together.
Exactly. And Singapore's model shows that effective water management isn't just about dams or pipelines. It's built on trust, transparency, and public participation.
And with that, we wrap up our deep dive into Singapore's water and wastewater management journey. In this episode, we've seen how a country under severe water stress developed a highly effective, sustainable, and technology-driven system.
And while preparing this episode, we not only consulted scientific articles, but also official sources from institutions like PUB, Singapore's National Water Agency. So everything we've shared is grounded in both technical and academic accuracy.
When we create these episodes, we bring together our academic expertise in environmental engineering, hands-on experience, and up-to-date resources. Our goal isn't just to provide technical information, but to explain how these systems work in real life, under what conditions they succeed, and why similar approaches might fail elsewhere. And of course, this is just the beginning. In future episodes, we'll explore water and wastewater management practices from different cities and countries, places dealing with drought, others facing floods, and everything in between. If you're interested in water management, environmental engineering, or building sustainable cities, don't forget to follow us on Spotify, YouTube, and Instagram. Subscribe to our channel and stay updated on new episodes.
Water is a critical issue for our future. As environmental engineers and researchers, we want to make this knowledge accessible and understandable. Thank you for joining us on this journey.
See you in the next episode. Take care.